Good morning. In this video, I'm to introduce the relationship between molecular structure and the strength of acids and bases. You should watch this video after you watch the AP Classroom video 1. This video approaches the topic from a different and more practical perspective. However, the AP Classroom video introduces the theory. This video approaches the topic from an organic chemistry perspective that, in my opinion, is easier to understand. We build on the premise that by definition, an acid gives away hydrogen plus proton and results in a conjugate base usually carrying a partial negative charge. What does that mean? When I look at ammonia, this is acting as an acid or HA. So in this case, it's NH3. It's going to give away a hydrogen. So this hydrogen here is being given away. And leaving this single bond, a single bond implies two electrons. So those two electrons are going to go to this nitrogen. So the conjugate base, or A minus, my conjugate base, is going to only contain two hydrogens instead of three here, but a negative charge on that nitrogen because these two electrons go onto the nitrogen. Same thing with water. Hydrogen goes away, this single bond or the two electrons go onto the oxygen, becomes the conjugate base OH minus. In the case of HF, gives away hydrogen, the single bond becomes the two electrons on fluorine, the conjugate base will carry a negative charge. I'm going to claim that the presence of an electronegative atom stabilizes the negative charge on the conjugate base, thereby increasing the acidity of the corresponding acid. What does that mean? Electronegativity is the ability of an electron to attract shared electrons in a chemical bond. An acid HA becomes a conjugate base, A minus. It does not like the fact that the conjugate base has a negative charge. So you can, in other words, you can see that atoms or molecules are unhappy because of the negative charge after the acid gives away a hydrogen. There are just too many electrons. If there are a lot of adjacent electronegative atoms, it shares a burden of that negative charge and hence stabilizes the conjugate base. If the conjugate base is stable, note that stable is not the same as strong. The corresponding acid is a strong acid. So the more stable the conjugate base is, the stronger the acid. Let's look at this example. In this case, I have four different compounds, and they're all acids. Remember that electronegativity increases as you go across the periodic table. So fluorine is going to have the highest electronegativity. The lowest will be carbon. In those four structures, in some ways they are identical in that it's all hydrogen connected to an adjacent atom. Here, hydrogen is connected to fluorine, here to oxygen, here to nitrogen, here to carbon. The most electronegative one is fluorine. Because fluorine is more electronegative after hydrogen goes away, fluorine is happy to bear that negative charge because it attracts electrons due to its high electronegativity. As such, this is the most F minus is going to be the most stable conjugate base because F minus is very electronegative. As a result, HF is going to be the stronger acid in comparison to the other three. So you only look at the neighboring atoms. So let's look at this example. Acetic acid gives away a hydrogen to become acetate conjugate base. In that conjugate base, the partial negative charge is on that oxygen. Let's compare that structure to ethanol. Ethanol has a carbon, hydrogen, hydrogen in its adjacent group in addition to that oxygen. After the hydrogen gives away, after this hydrogen is being given away, the oxygen also bears a partial negative charge. If you compare those two structures vertically if you compare those two conjugate bases. In the case of acetate, I have two very electronegative oxygens shares the burden from that negative charge. Versus here, oxygen is much more electronegative than the hydrogen, so there's not much to share that negative charge. And you can say that acetate is going to be a stronger acid because there are more adjacent electronegative groups to share the burden from that negative charge. So in this case, you not only look at the adjacent atom, but you can look at the groups that are nearby. So here I have two hydrogens in proximity. Here two oxygens in proximity. Here I have an oxygen and a hydrogen. The two oxygen one is going to be much more electronegative and draws more electrons towards it. So therefore, I can say that acetic acid is stronger than ethanol. I can also say that acetate conjugate base is much more stable than ethanoate. Let's look at this example. Which hydrogen would be given away first? In other words, the one that will be given away first is the most acidic hydrogen. You can put it that way. What this question is essentially asking is that which side will be more stable after the hydrogen is given away. Let's consider group 1. Group 1 has no hydrogen, so obviously that is not going to be the answer. For group 2, in its proximity, I have two carbons, three hydrogens, and an oxygen. The oxygen is more electronegative, but it's far away. In case 3, I have an oxygen right next to a hydrogen. Oxygen is very electronegative, so it can carry the partial negative charge after you give away the hydrogen. Also, not only that, but you have another oxygen in proximity. So therefore, I'm going to say that the hydrogen in 3 is the most acidic hydrogen that will be given away in Bronsted acid reaction since it's connected to the most electronegative atoms. When we consider bases, a strong acid is a weak base. So the way I think about this, I just look at how acidic everything is. And if the question asks for which one is the strongest base, the weakest acid is going to be your strongest base. And the strongest acid is going to be your weakest base. In an example, if the question asks which one is the strongest acid, you can look at those structures, look at those hydrogens. It seems like this hydrogen is next to very electronegative groups with two oxygens, versus this only has one, and those are really carbons. So therefore, I'm going to say that the middle one is the most acidic compound. But what if the question asks which one is the strongest base? I know that this one is probably my weakest base because all the hydrogens are connected to carbons instead of oxygens, and carbons is much less electronegative. So this is my weakest acid, and by definition, the weakest acid is going to be your strongest base. So I'll finish the video after I finish writing this. So this is the weakest acid, therefore it will be the strong base.